Hello, my dear students. It's a pleasure to meet you in our educational program of Environmental Sciences and Geology. In our today's program, we will have a general revision in forms of questions and answers. Let's start with the following. Let's start with the following question. What are the structural types of the diagram in the front view? As you see, my dear students, this diagram is showing grabens and horst. These types of structures developed when the two hanging walls of the normal faults combine with each other in one rock block. So we have this graben in the front view. And the two sides of the diagram we have horsts. They are also structures developed when the two footwall of two normal faults combine with each other in one rock block. Right on the soil horizon. As you see, my dear students, we have some horizons for the soil. We have the uppermost horizon, which is the A horizon. It is commonly grayish in color, because of the addition of humus resulting from the decay of plant roots and animal tissues. The A horizon is described as a zone of leaching, because percolating water moves the soluble salts and the fine clay particles downward to the underlying horizon, which is the B horizon. The subsoil horizon or B horizon is also known as the zone of accumulation because it has grained part of the soluble salts and iron oxides leached from the A horizon. Also, the B horizon is containing the small amount of organic matter. The C horizon is slightly altered bedrock of the bedrock and decayed or decomposed fragments mixed with clay. It rests on the parent rock. It is not part of the soil itself because plant roots rarely reach to the C horizon. Now let's go to this question, how the Egyptian government solves the problem of soil erosion. The agricultural land in Egypt was exposed to a big destruction process. The state has issued restricted laws to prevent the manufacture of red bricks from the soil of the agricultural land since August 1985. Factories for making bricks from clay or cement or other substances in order to save the agricultural soil from destruction were established. Also, we have the following question, which is the following organisms would probably belong to the same trophic level as a bear. We have some organisms like deer, oak tree, wolf, and cow. The one here which is in the same trophic level of bear, it is the wolf. Bottom fish are found in which trophic level? Is it in the second trophic level, third trophic level, or fourth trophic level, or it is in the last trophic level? As you see, my dear students, bottom fish, they are decomposers. They are found in the last trophic level. Delta usually formed in river stage. Which river stage? It is capture, youth, mature, or old stage. As you know, my dear students, in the stage of old river stage. The river reaches to the sea and start making its deltas. So the stage here is the old stage of the river. The river terraces are in which stage? Is it in rejuvenation stage, mature stage, Yas stage, or old stage? We know that the river starts making its terraces at rejuvenation stage, which is the first choice. Which of the following elements are represented by a percentage over than 25% by way of the rocks of the crust? We have the following elements like silica, aluminum, magnesium, and iron. And the element here which is more than 25% in the rocks of the Earth's crust, it is the silica. Which of the following elements are represented by a percentage less than 5% by weight of the rocks of the crust? As you see, my dear students, we have some elements like oxygen, aluminum, magnesium, and iron, and the one here which is less than 5%, it is the iron element, which is the D answer. You discovered a rock with aphanetic texture containing amphiboles, biotite, and sodium feldspars. This rock is called gabbro, granite, basalt, andesite, or diorite. This is the criteria of the rock you discovered. It is aphanetic texture containing amphiboles, biotite, and sodium feldspars, and this is the andesite. For the same rock, we have the following question. Is it volcanic rock, plutonic, porphyritic, highly weathered? None of these. Simply, it is volcanic rock. How can animal adapted for temperature changes? We have spore and cyst, protozoa and germ in bacteria. This is a kind of modification. Also, we have hibernation of some amphibian and reptiles when the temperature decrease or increase. We have hibernation for some animals. Also, we have summer laziness, means escaping from temperatures such as mollusks, insects, and some reptiles. And this is summer laziness. We have also migration of some animals to other areas when temperature is not suitable. My dear students, let's go to the next question. Sodium chloride, when found in rocks, it forms and could be referred to as sodium chloride and rocks. The rock form of the sodium chloride, it is the rock salt. A rock that is the result of compaction of variably decayed plant matter is referred to as this type of rock, which is formed from the decay of plant that is cool. We have sediment always carried above the river's bed in the moving current. It's classified as sediments always carried above the river bed. Is it solution load, bed load, suspension load, continuous load, or none of the above? As you see, my dear students, the way the sediment is moved in the river, it can take different forms, like being in solution, or in the bed load, or suspension carried on the water, or in continuous load, or none of the above. And this is which carried in the water, it is the suspended load, which is the C answer. Alluvial fans develop at the base of which? Is it the continental shelf, the continental slope, the mountainous front, or fault scarp, or none of the above? Yes, the right answer, it is the mountains fronts where the river coming out with very high velocity and then start to form the alluvial fan. When rivers enter large bodies of standing water, they typically depush their load, forming which kind of the rock forms? The rivers can form it when it is entering to standing water. Is this form? It is alluvial fans, submarine fans, barrier islands, deltas, or none of the above. As you see, my dear students, in entering in standing water, the river starts to form deltas, which is the D choice. Now let's go to the next question. Strips of sands and gravels lying above sea level and parallel to the adjacent coastline but separating from it by a narrow body of water. This strip of sands are called alluvial fans, submarine fans, barrier islands, delta, or none of the above. As you see, my dear students, the form of this sand, it is parallel to the coastline, and sometimes they close an area of the coast and form a lagoon, and we know this by barrier islands. What do you call accumulation of sands that are the result of blowing wind? Of course, we call this dunes or sand dunes. Gravels, including pebbles, are pieces of older rocks, material greater than, its grain, it's greater than 2 millimeters, 4 millimeters, 64 millimeters, 256 millimeters, or 0.06 millimeters. Gravels, we know its classes or its component fragment. Mostly they are greater than 2 millimeters. So we call this conglomerate. A sedimentary rock composed of rounded gravels is called, this is a definition for conglomerate. It is sedimentary rock composed of rounded gravels, and it is called conglomerate. In quaternary, we have another sedimentary rock composed of angular gravel, and this time we call this rock, which is very similar to the conglomerate, but we call this sharp-edged rock breccia. The largest class size and the range of gravel is, we expect here a name equivalent to this large particle. It is pebble, cobble, very coarse sand, or boulder. As you see, my dear student, boulder is the large size in this scale. It's not pebble, cobble, or even not the last choice, none of these of above. It is boulder, which is the right answer. Sand is cohesionless sediment ranging in size between 0.06 and 2 millimeters. Sand is cohesionless sediment ranging in size between 0.06 millimeter and 2 millimeter in size. However, mudstone is composed of particles ranging in size from less than 0.004, this is the right millimeters, to 0.06 millimeter size. The process of reducing pore spaces by depositing younger sediments on top of older material is referred to. This process leads to decreasing the pores in the sediments. This process is dilation, reduction, contraction, compaction, or none of the above. As you see, my dear students, the process which leads to reducing the porosity or the pore space of the rock because of the overlying sediments, this is a compaction, which is the right choice here. This is the process of compaction. Now let's go to the next question. The cement in a sandstone is typically the result of precipitation of mineral like quartz and calcite, from which come this cement. Which form it is coming in? It is coming from the atmosphere, organisms, fauna, flora, or solutions. Yes, the right choice here. This cement are coming from solutions passing the rock and containing many elements, and they start to deposit in the pores of these sediments as cement. So the right choice here is the E choice, solutions. What happens if rainwater collected in the inactive volcanic vent? We start having a rounded lake. What happens if groundwater saturated with carbon dioxide percolate limestone rock? It's a big problem because groundwater will be acidic by dissolving carbon dioxide and act as weak acid. Completely dissolve rocks such as limestone and widen joints and fractures, forming wide caves in limestone. And when the condition come to adverse or changed to the adverse and are not suitable for dissolve the limestone, they start deposition of calcite from the water, percolating limestones, so as a sediment like stalactite, which are hanging from the ceiling, and stalagmites, which are projecting upward from the floor of a limestone cave. It means it forms dripstones. Dripstones are stalactite and stalagmites. Stalactite, as you see, coming from the ceiling of the cave, and stalagmites are projecting upward from the floor of the cave. What happens if orthoclase is subjected to chemical weathering? Orthoclase composed of potassium aluminum silicate, and this is a weak mineral under the effect of carbonic acid formed by the dissolving of carbon dioxide in rainwater. Hydrogen ions released from the diluted carbonic acid and attack orthoclase and will decompose it by losing silica and potassium to give kaolinite, which is a common mineral of clay minerals. A river meets the sea. A delta forms whereas the river deposits sediments faster than the sea can remove it. Nile deltas, as an example, have deposits with economic importance such as gold, diamond, antimony, and limonite. In Egypt, the black sand appears in North Delta regions as well as in Rashid Coast until El Arish in east, and contain monazite minerals, which are sometimes containing radioactive minerals, limonite and zircon, which are used in ceramics. Water table near to the stream or lakes. We expect water tables near streams or lakes to be close to the ground surface because much of the water percolated to the underground, and this will rise the water table. Water table in desert or mountainous regions. In the adverse, the water table lies at greater depths. We don't have much discharge or frequent water to go to this underground aquifers, so the water table lies at greater depth. Fill in the space. In the energy pyramid, each trophic level contains space of the energy as one fluid. The lost percent mostly transferred to which space? Thus, if we started with which kilograms of phytoplanktons, only space kilograms of it will move to the following trophic level in the zooplankton. It will become space in small fish, space in large fish, and 0.0 kilograms in shark or whale, and finally it will be space in man if he fed on these farms. As you see, my dear students, this is the energy pyramid. It is depend on the loss on the amount of food changing from one trophic level to the another one, and only 10% of this food will be valuable for the next trophic level, and the loss will be the changes or the changed energy. The energy pyramid in each trophic level contains 10% of the energy as one fluid. The lost percent mostly transferred to heat. For example, if we start with this our example, 1,000 kilograms of phytoplanktons, which is the first trophic level in our example, the next will be only 100 kilograms, which is the zooplankton. Of it will move to the following trophic level in the form of zooplanktons. And also we have another trophic level, and it will become only 10 kilograms in a small fish, which is the third trophic level. It's only 1 kilogram in large fish and 0.1 kilograms in shark or whales, and finally it will be 0.01 in man if he fed on these farms. Give some examples of chemical weathering. We have the following examples like water dissolution. Water, especially when it contains some dissolved matter, is a very effective agent of chemical weathering. It usually leads to decomposition of the original mineral and decaying of rocks by changing the mineral composition. The original minerals are changed to new ones, more stable to the near surface conditions. We have also oxidation in this type of chemical weathering. Atmospheric oxygen attacks ferromagnesium minerals. Those minerals of which iron and magnesium are the main components, main constituents, in the same way as when an iron waster pipe rusted when iron is changed to iron oxides. So this is a good example for oxidation in the minerals containing iron and magnesium. We call them ferromagnesium minerals, and the example as the rusting of the iron pipes. We have also hydration. It is another process of chemical weathering. It implies that water becomes part of the chemical composition of an originally anhydrous mineral. So we have intruded OH atom to the mineral. A common example is the hydration of anhydride calcium sulfate to gypsum. Chemical weathering of igneous and metamorphic rock where silicate minerals, they are also decayed. They are like potassium feldspars and sodium calcium aluminum silicates and ferromagnesium minerals silicates of iron and magnesium. All of these are different minerals of the hard rocks. They are altered to clay minerals which make the major part of soils. What are the animal photoperiodic types? Light or sunlight has great effect on the activity of animals. According to that, there are 4 photoperiodic types of animals during the day. We have the dawn period animals. The activity of the night animals are reduces, so they go to their homes. Also, we have the day period animals. The day animals become active. Also, we have the sunset period. It is important for some animals. The activity of the day animals is reduced gradually and the animals go to their homes. And also we have the night period animals. In this period, the night animals are active. By this, my dear students, we come to the end of our programs. I hope the best for you for tomorrow's exam. And goodbye.